Okay, so we talked about vertical asymptotes. We defined them, and now it's time to see how we can find these vertical asymptotes and do this algebraically. And the general idea here is to look for values where f of x is undefined. Okay? In fact, looking for values where we would have a division by 0. And to kind of explain why we do that, now let me just graph this function here. So I'm going to type in 2x squared divided by x squared minus 9 and graph it. Okay, and I'm going to zoom out of here. I'm going to use my zoom standard. Okay. And you can see here in the graph that it's actually drawing in these two vertical lines. They're not part of the graph, they're actually asymptotes. My calculator is trying to draw in vertical asymptotes here for me. And you can see that they occur right around 3 and -3. Okay? And you can also see that the graph itself, the actual curves, get closer and closer to this line, but they never actually touch it. From the left, it gets closer and closer. It goes towards y values, goes towards positive infinity. X values get closer, but never actually touch it. Same thing here. In this direction, I go from the left to the right. It goes down. The actual curve gets closer to that line, but never actually touches it. Okay, and the reason that it never actually touches it is because it's probably undefined. If it's undefined there, that means there cannot be any x values there, and so it's probably there that's our vertical asymptotes. Okay, and we're working almost exclusively here with rational functions, functions that have a fraction, numerator and denominator. And so we're looking for places where it's going to be undefined or where the denominator is 0. So I'm actually going to set the denominator equal to 0 and solve for x. Because remember, vertical asymptotes is specific x values. It's vertical lines. So once again, this vertical line here is where x equals 3. This vertical line here is x equals -3. At least it looks that way. So I'm going to use that as my guide and try to solve here for the denominator when it's equal to 0. Get x squared is equal to positive 9. I want to take the square root of both sides. So I get x is equal to plus or minus the square root of 9, which means that x can be positive 3 or x can be -3. Okay? And what these numbers mean is that's where my vertical asymptotes are going to be. And once again, one of the themes here is that if we want to find something out for sure, the best way to do it is start with the graph and to do it algebraically, and then compare the two results so that we can see that they match up. And you can see that my algebraic steps here showed me that it's going to be x equals 3 and x equals -3, and that corresponds to the asymptotes here on the graph. And my TI-83 has a really nice feature in the trace. So if I hit trace and I hit 3, x equals 3, you can see here that y is equal to blank. That means it's undefined there, and that's where the asymptote, the vertical asymptote, occurs. And I can try the same thing, x equals -3, and you see I have a similar result where y is just blank, and that's because at -3, at x equals -3, the graph is undefined. I can also go to my table, and I'm going to change my table set to start at -3, hit graph, and you can see at -3 it actually says error, and also at +3 it actually says error. And that's the reason is because there is no value there, because if it was 3 or -3, the denominator would be 0. So when we're looking for vertical asymptotes, we're actually looking for holes or gaps, and in fact we're looking for infinite discontinuity in our graph, if you remember from our discussion on continuity. So there you have it. To recap here, you set the denominator equal to 0, you solve for x, and make sure that you check it by graphing.